You know what a tardigrade is, right? Maybe you've seen one online. Little blob, 8 legs, moves like it's underwater even when it's not. People call them water bears or moss piglets, which is honestly worse. They're small, really small, half a millimeter if they're doing well. You'd need a microscope to see one properly, but that's not the interesting part. The interesting part is what happens when things go wrong. Let's say the water dries up, most things that size, done. Cells rupture, proteins fall apart. That's it. Tardigrades do something else. They pull their legs in, the body compresses. All the water inside, it just leaves. Slowly. And as it does, the cells fill with something else. Sugars mostly. Thick ones. They coat everything. Membranes, proteins, DNA. Everything that would normally collapse without water just gets held in place. And then it stops. Completely. No metabolism, no repair, no aging. The thing that was alive isn't alive anymore, but it's not dead either. This state, people call it a ton, which is just a word for the shape. Barrel-shaped, compact, but calling it dormant makes it sound temporary. This can last decades. Longer, maybe. No one's really sure yet you can freeze it, boil it, stick it in a vacuum, dose it with radiation that would shred most DNA into confetti. It doesn't care. Well, no, it's not that it doesn't care. It's that there's nothing running that could care. The systems that would normally detect damage, offline. The processes that would try to fix things, off. But here's the thing. When water comes back, if it comes back, it reverses. The sugars dissolve, the cells reinflate, proteins snap back into shape. And then, like someone just unpaused it, the tardigrade starts moving again. Same one, same cells. Just resumed. You'd think there'd be limits to this. There are. Sort of. If it dries out too fast, the cells don't have time to protect themselves. Everything breaks. If it heats up while it's dried out, the sugars start to caramelize. That's not a metaphor. They actually do. And once that happens, it's over. But if the conditions are right, or just right enough, it works. They've been found in the Himalayas, in deep ocean vents, in Antarctic ice, in deserts, in urban moss that hasn't been wet in months. They don't live there exactly. That makes it sound like they're thriving. They're not. They're just not dying, which, over enough time, turns out to be the same thing. Most animals need stability, consistent temperature, consistent moisture. Tardigrades need the opposite. They need variability, because that's what they're built for, not comfort. Just interruption and recovery. Over and over. You'd think evolution would have upgraded this by now? Like, okay, you survived the dry spell, great. Now let's make you bigger, faster, better at something. Didn't happen. Tardigrades have been around for at least 500 million years. Probably longer. Fossil records spotty for things this small. But the body plan hasn't changed much. 8 legs. Claws on the ends, sharp ones, hooked, good for gripping moss or algae or sand grains. No real eyes, just light-sensitive spots. Enough to know if it's day or not, that's about it. The mouth is weird. It's a tube, retractable, lined with stylets, basically tiny spears. They punch through plant cells or algae or bacteria and just suck out the insides. Not fast, not elegant. But it works. They don't hunt. They're too slow for that. They just eat what's in front of them. And if there's nothing in front of them, they stop eating. Then they dry out. Then they wait. You'd think that would be stressful. It's not. There's no learning involved, no memory, no adjustment. They don't get better at surviving. They just survive. The same way, every time. And that's enough. Reproduction is simple. Some lay eggs, some don't. Some are male, some are female. Some are both. Some reproduce without males at all. No courtship, no care. The eggs dry out too if they need to. Then they hatch later. Or they don't. No strategy, just outcomes. It's not that they're tough. That makes it sound like they're enduring something. They're not. They've just removed the need to endure. Most life is based on keeping things constant. Homeostasis, internal regulation. Tardigrades gave that up. They let the outside in, and when the outside becomes unlivable, they stop being alive. Then they start again. You'd think that would be rare? It's not. There are over 1,000 species, maybe more. They're everywhere. You've probably walked past hundreds of them today, in the cracks of sidewalks, on the side of a building, in the soil of a houseplant you haven't watered in a while. They're not doing well. They're not doing poorly. They're just there. People get excited about the extremes, the radiation tolerance, the vacuum exposure. And yeah, those are real. Someone just wondered, what if we sent them up? Not because tardigrades had anything to do with space, but because if they can survive drying out, maybe they can survive nothing. So in 2007, they did it. They attached a container of tardigrades to the outside of a satellite. No protection. Just out there, in the vacuum. Direct exposure to solar radiation. UV levels that would cook most DNA in minutes. Temperature swings from boiling to frozen over and over. 10 days of that. Then they brought them back. Most of them were dead. That's important. This isn't some miracle story. Most didn't make it, but some did. They rehydrated them. And a portion, not all, but enough, just started moving again. Like nothing happened. A few even reproduced afterward. Laid eggs, viable ones. You'd think this means they're built for space. They're not. There's nothing in their evolutionary history that involves a vacuum. No ancestor ever needed to survive cosmic radiation. Moss doesn't grow in orbit. But here's what happened. When a tardigrade dries out, it stops everything. No metabolism means no oxygen use, which means no breathing, which means it doesn't need air. The vacuum didn't matter. It was already not breathing. The proteins were already locked in sugar. The DNA was already coiled up tight. The damage from radiation? It still happened, but the repair systems, the ones that fix breaks in DNA, they turned back on when the water came back. And they just worked. Slowly, not perfectly, but enough. The cold didn't matter either. When you're dried out, temperature's just temperature. There's no liquid to freeze, no cells to rupture. It's like trying to freeze a rock. You can, but nothing breaks. So the space exposure didn't teach them anything. It didn't test some hidden ability. It just revealed what was already there. The same systems that let them survive a dried-out puddle in a parking lot turned out to scale. They've done more tests since then. Longer exposures, higher radiation. Same results mostly. Some survive, some don't. The ones that do aren't tougher. They're just luckier, maybe. Or their DNA took fewer hits in the right places. People started talking about panspermia after that. The idea that life could travel between planets. On asteroids, in debris. And yeah, if anything could survive that trip, tardigrades are on the list. But let's be clear, surviving the trip isn't the same as surviving the landing. Or the new planet. They'd still need water. They'd still need food. They'd still need to be somewhere wet enough, often enough, to actually live instead of just not dying. Space didn't make them special. It just showed they'd already solved a problem they didn't know existed. Tardigrades didn't evolve to survive space. They evolved to survive Tuesday. And that turned out to be enough.